If the radius of a balloon is increasing, how fast is the volume increasing? That's a related rates problem. And today, you'll learn a simple 5-step system that works every time. What are related rates? Related rates are problems that involve two or more quantities that are all changing with respect to time and connected by a formula. We use derivatives to connect their rate of change. Here's the 5-step system. This approach eliminates confusion and ensures you never miss a critical detail. First, determine which quantities are changing with time. Then, relate these quantities with a formula and even draw a diagram if it is helpful. Then you'll differentiate both sides with respect to time t, plug in given values for variables and rates, and finally solve for the unknown rate and explain your answer. Here's the first example. We have an expanding circle. The radius of a circle is increasing at 3 centimeters per second. How fast is the area increasing when the radius is 5 centimeters? So in this case, we're given the rate of change of the radius. So dr dt is 3 centimeters per second. And we know that the radius is 5. And we're looking for how fast the area is increasing. So that will be the rate of change of the area with respect to time. So dA dt. Now, the formula for the area of a circle is A equals pi r squared. We can differentiate that with respect to t. So that will become dA dt is equal to pi times the derivative of r squared is 2r times dr dt. Substituting the given values, we know that dr dt is 3, the radius is 5, so dA dt will be equal to 2 pi 5 times 3, which is 30 pi. Therefore, the area is increasing because our related rate is positive. The area is increasing at the rate of 30 pi centimeters squared per second. In this next example, we have a ladder sliding down a wall. A 10-foot ladder leans against a wall. The bottom slides away at 2 feet per second. How fast is the top sliding down when the bottom is 6 feet from the wall? So my hypotenuse in this case, we have a right triangle. So my hypotenuse is 10. We're looking at how fast is the top sliding down when the bottom is 6 feet from the wall. So that will be our x. And using the Pythagorean theorem, we can find y, or the height on the wall. Now, we're given the rate for dx dt, that's how fast the bottom slides away, and that is 2 feet per second. We're looking for how fast is the top sliding down right here. So that will be dy dt. That's what we're looking for. First, let's set up our equation. Our right triangle formula is x squared plus y squared equals 100. So we can differentiate our equation. That will be 2x times dx dt plus 2y times dy dt equals 0. So we can solve for y by using the Pythagorean theorem. When x equals 6, if we substitute x equals 6 into our equation, that will be 36 plus y squared equals 100. And therefore, y squared will be equal to 100 minus 36, which is 64. And y will be equal to the square root of 64, which is 8. Now, we can substitute our given values. So x is 6, dx dt is 2, and we found that y is 8, and we're looking for dy dt. So that will be 2 times 6 times 2 plus 2 times 8 dy dt. And solving for dy dt, we'll find that that is equal to negative 1.5 feet per second. The negative sign indicates decreasing height. So the top of the ladder is sliding down at the rate of 1.5 feet per second. Let's look at this next example about profit growth. A company's profit depends on production units. The profit function is P equals 5x squared minus 20x, where P is profit in dollars and x is the number of units produced. So in this case, the production rate, dx dt, is 3 units per day. The question is, how fast is profit increasing when x equals 10? In other words, find dp dt when the production is 10 units. So differentiating our equation with respect to time, dp dt will be equal to 10x minus 20 times dx dt. And if we substitute x equals 10, and we know that dx dt is 3, that will be equal to dp dt is equal to 100 minus 20 times 3, which is 80 times 3, which is 240. In other words, the profit is increasing at the rate of $240 per day when 10 units are being produced. Here are the essential patterns to remember. Even if it doesn't appear explicitly in the equation, you're always differentiating with respect to time. The chain rule naturally emerges when differentiating composite function with respect to time. And pay careful attention to units throughout your solution. They help verify that your answer makes sense. Here's your challenge for today. The volume of a sphere is increasing at the rate of 10 centimeter cubed per second. How fast is the radius increasing when the radius is 2 centimeters? And I gave you the formula for the volume of a sphere. V is equal to 4/3 pi r cubed. Related rates problems are not about memorizing tricks. They are about identifying relationships, differentiating with respect to time, and solving for rates. If you follow the 5 steps, every related rates problem becomes manageable. Thanks for watching. Please like, subscribe, and remember, math success starts when you stay on the fast track.